at that right now. Thank you for the reminder. Okay, so I think that's enough of the announcements. Any questions about anything going on? Oh, I want to say one more thing about WebAssign, that there's one due as usual on Sunday. And I worked with a couple of people directly on WebAssign, and I found that very efficient. So if that's something you're interested in doing, office hours are best, but we can find other times. And we were just screen sharing just to sort of go over sort of some of the idiosyncrasies of WebAssign. So again, that's something that I'll put out there. Okay, we're gonna, before we go into small groups, again, any questions? And then I was going to just talk a little bit, give a mathematical introduction, and then we'll just go into it. So if you don't have the other me up there, you know, with the other Daniel Alexander, the one that has the notes, you know, pin it so you can see them. So I'm just gonna go into a brief explanation. Okay, so I'm just going to give an overview, and when my camera has just gotten foggy. I don't know what's going on. So I'll talk through it, and then we'll see what happens in a second. Not sure what's going on. I might have to log out and log back in again for that feed. That has worked before. Let me switch the camera and see if that helps. Sorry for the technical glitch there. Okay. Well, it seems to be cleared up. I just have to get it centered again. Sorry. Okay, sorry for that delay. Okay, so what we're talking about are logs, and when I've taught this course before, which has been a while, logs are one of the things that if you're learning them can be really confusing. There's just something inherently about it. So I just want to sort of go through one example to try to explain it and say a couple of things about logs, and then we'll go into the group exercise. So hopefully this is less. It was blurry a moment ago. Okay, good. So if we have something like, I'll just give an example, like 10 to the third equal 1,000. I'm sorry, that would be 10,000. No, that would be 1,000, sorry. That's the exponential relation. And it looks like it's of this format. Something that looks like that, okay. And then if I want to reverse it, if I want to focus in on this, figure out what this x is equal, which is essentially the inverse of that, I look at the log base A of C. And this log, what it does is it finds the exponent for C. So this, if I want to find what exponent of A gives me C, I just take the log. Now the thing is, just taking the log is impossible by hand, except if you have something like this up here, which I'll go through in a second. And so that's why you have to use a calculator. It's a very mysterious, in order to how this actually works to compute, it's kind of mysterious, and it's a subject that's beyond what we do in our class. So if I wanted to write this relationship as a log, I would put the exponent here, and then that would be the log. This number 10 is the base 10 of 1,000, and that would equal 3. So the idea is that this conveys exactly the same information as that. And so you know, some of the stuff you're going to do today, and also on WebAssign, is to write something in this form, So in other words, you want to, if you have a relationship like this, you want to write it log the base, that's A, the number whose exponent you're trying to get is equal to, and that's equal to X. So this double arrow means you can go either way. You can go from one to the other. So that's one of the skills, and a lot of today is based on reinforcing that. So just some simple computations. So that's one of the things I wanted to talk about. And really what's going on here is that these are inverses. This is a number, a base to a number, a base to a power gives me a number. The inverse says, here's the base, here's the power, there's the number. So it just reverses the relationship. I talk more about that in the video. I just want to go over that one more time here. And a lot of the WebAssign problems have you do that kind of thing. And the second is just to directly evaluate the log. I go into this later today, but later in the videos for Thursday. But basically, there's two logs that are used a lot. One is the log base 10, and if you see something on your calculator that says log, what it really means is log base 10. They're not writing the log. And then the other log is what's called the natural log. And it says ln, and that's really the base e, where e is that number we talked about last week. It's about 2.718 so far, So anyways, I just wanted to go over those two things. Okay. And then the last thing I wanted to talk about is end behavior. Like, I thought the exams were really, really good. The scores were as an average pretty high. And so, but one of the things about end behavior, it was clear people were having some questions about that. And I could have explained that better. So I want to go over that just one more time, because it's going to apply to what we're doing today. So I'm going to look at the graph of y equal 10 to the x as an example. And it looks like this. And then the end behavior. I just wanted to give us some better language for it, which I probably should have done in the first place. Over here, we're seeing that the graph approaches the horizontal asymptote y equals 0. So that would mean as x approaches minus infinity, in other words, as you're going this way, the graph approaches 0. So that's one way to talk about end behavior. Over here, we're seeing that as x gets large, so in other words, as x goes to infinity, the graph goes to infinity. So over here, you would say, as x approaches infinity, the y is also approaching infinity. And so I think this is a good language to use. I was trying to avoid it, but I think that was wrong. And so when you say this is as x gets large in a negative direction, to say that is the same as saying this. Those mean the same thing. And when I write as x approaches infinity, that's the same as saying as x gets large in a positive direction. Okay, so again, I'm going to start using that language because I think it's a simpler language than trying to describe it in words. And then I wanted to talk about a vertical asymptote, and then we'll go into the small groups. So you'll see in the videos and hopefully today that this is what the graph of the log looks like. And here, the graph gets large in a negative direction. As x gets near 0. That's how you say it in English, but the better way to say it, I think mathematically, is x approaches 0 from the right. In other words, you're going from this direction. Y approaches negative infinity. So that's a good way to describe what's going on right here with a vertical asymptote. And then again, over here, as the graph goes off to infinity, you would say as x gets large in a positive direction, as x goes to infinity, so does y. But it goes slowly. You don't need to write that down. I'm just letting you know that if you look at this graph, it takes a long time for it to get to infinity. I just wanted to point that out. Okay, so I just wanted to introduce that language. It's in the text, and I really should have used it before. And just give you a brief intro into logs, just to sort of, and then today it's just getting used to this idea of what a log is. I'm assuming that Some of you have seen it, but I'm assuming a lot of you haven't before. Okay, so I'm going to break into small groups, but as I get that set up, are there any questions? Okay, so I am going to okay, we got it. Okay, I'm going to open up the rooms. Remember, it's handout 13. Hi, Katie and Sydney and Mitch. Are you having issues joining the rooms? I know that's happened before. So I can't hear you. Katie, are you here? Are you hearing me at all? And same with you, Mitch?
Yeah, I just typed in the chat. It's
Yeah,
not letting me join for some reason.
okay, I'm going to be in the main room. What's happened, this has happened before. If somebody has logs out and then comes back in, that often works. And then I'll just assign you to a group. I'm not, so I don't know why this happens, but I noticed it's been happening more lately.
Okay.
Okay. Katie, if you're here, if you heard that. Okay, I got to see. Do you remember what room you were? I'm going to put you in room 3, Mitch. It looks like they.
Okay.
Okay. I don't know what room you were in before, but it's giving me that opportunity. So good. So I'll see you in room 3.
Sounds good.
Okay. Hi, Thomas. Hi, Thomas. You should go into room 1.
Hey, sorry. I just disconnected, and when I came back, it was not working.
That's what I figured. I noticed you were. It took a while for you to get in. You were in group 1, right?
I wasn't actually
Oh, you
assigned.
never get it. Okay, yeah. Are you getting an offer to join a room?
No.
Okay. So it thinks you're in group 1. So I'm going to move you back. See if this helps.
Okay.
I don't have that option to do that. So let's try it. I'm going to move you into room 2 and then move you back to room 1 where you were. See if that works.
Okay.
If that doesn't work, then I would say log back in again. That's worked for other people before, but this is kind of one I haven't seen before. Okay, I'm going to put you in room. Actually, what's easier if I'm looking for a room where there's just a small number of people. You were in that room. Okay. No, room 2 will work. Okay, I'll just put you there. Is that giving you the opportunity now to join it?
I don't see anything.
Okay. Yeah.
Okay, I'll just leave and come back and see if that works.
Yeah. Yeah. Try that. Okay. Just to check in on you and see where you are.
We're still kind of like, I'm currently I got to 2 and I'm kind of messing around with some of those graphs.
Okay. What do you see? What do you see in 1? This is to everybody.
They're just like reflections, and then when you moved the slider back and forth, they would expand like outwards. Is
Yeah.
kind of how I would describe it.
Yeah. Yeah. The idea is just to see. Yeah. That's a good way to see it. As A gets bigger, it sort of gets closer to the y-axis. And as A gets smaller, it's gonna expand way out the graph. Is that what you're seeing?
Yeah.
Yeah. Okay. Okay. Is everybody okay with using the slider?
Yes, I'm pretty good with it.
Okay. And getting it set up.
Yeah.
That's one of the things I wanted to make sure everybody knew how to do that.
Yeah. It took me like a couple seconds to figure it out.
Right.
Trying to get it to plug in and everything.
Yeah. Yeah. And it's useful to see like what happens when something changes. I think it just gives you a little bit more insight. Okay. And again, I didn't set the screen sharing at the beginning, which is my fault. So I set it now if you want to share the screen, so you can do that. Okay. If you want to discuss. So, okay. So it sounds like everybody's on track. No questions.
Oh, I have one for 3.
Sure.
Try to figure out the following log equations.
Yeah, I should have said solve, not figure out. That was bad language.
Okay.
Like what's X equal to?
Okay, that makes more sense.
Okay, sorry, I should have
just wanted to make sure.
Yeah. Yep. Okay. Okay, I'll see you all in a bit. Hello, I'm checking in again. I'm giving everybody sharing privileges. And so I just kind of wanted a couple of things for 1 and 2. Part of that's just understanding how to use the slider in Desmos. So I want to make sure everybody knows how to do that.
I don't know how to use it.
You said you do or you don't?
I don't.
Okay, here. I'll show you how to set it up. Okay. Oops, that's not what we want. Okay. So let me share. Okay, are you seeing the screen?
Yeah, I see it.
Okay, so I'm just going to put y equals a to the x, and I'm using an a, and because it's not a word, because it's not a number, and because it's not a usual variable. See how it says add slider? You click
Yeah,
on
okay.
you click on that, and it gives you a slider in the next cell, and you can move back and forth, and it changes the graph. So and then, but remember, because this is exponential, exponentials have to be positives. But I think what I'd like you to do is make this equal. Well, I'm going to make this. Doesn't make sense if a is negative. So I'm going to make that. I'm going to 1 or greater. And then if I move that slider, it just lets me to see what happens if I increase a, and what happens if I decrease it.
Okay, I see that.
Yeah, so anytime you add a graph, if you put a letter in it besides X or Y or E or T, it's going to say add slider, and you just click on that and you set up the slider.
Okay, thank you.
Okay, okay, good. Okay. So are there questions about anything? And if you've gone through number 1, what do you see? Someone tell me what they see there.
That they're reflected over the y-axis.
Yeah, I mean, if you just exactly, I mean, it's not terribly profound, but if I put like y equal 2 here to the x, I'm going to turn off the first one, and then I'm going to add y equals 2 to the minus x. You can, in purple, you see that they're just reflected across, and I just want you to, and that's because 2 to the x and 2 to the minus x are reciprocals. So it's kind of a warm-up just to get you to see that. Okay. Okay, now where are you in general? Are people still working on number 2? I'm just curious to know what number people are on.
I'm on number 2.
Number 2. Okay, good. And again, I encourage you, like, I mean, I'm able to share the screen. I mean, you can, like, if somebody has a question about something, ask the others, and then I encourage you to, like, when I have questions here, I encourage you to discuss, and then this is kind of the purpose of that, and then you know, show each other your work. It's a way to sort of help each other out, and you learn as you help somebody else, and if somebody helps you, you're learning as well. So, okay, just encourage you to do that. Okie doke. I'm not hearing other questions, but so let me know if you have one, and otherwise I'll see you later as I come through.
Thank you.
Okay, yep, okay. Take care. I'm just coming in to check in, make sure that you have sharing privileges. I just activated that. Like for 1 and 2, part of the purpose is just to make sure everybody knows how to add a slider within Desmos, and I'm wondering if there's any questions about that, whether anybody had difficulty doing that.
I actually skipped that part because I didn't know how to do it.
Oh, okay. Yeah, and that's perfectly okay. That's one of the reasons I want to make sure people know this, because I might use that in the lab at some point. I just want to make sure people have that skill. So I'm going to share my screen,
Okay.
and I'll show you. Yeah, I'm going to just take this stuff off because I already had it. I was showing somebody else in another group. Okay, so if I put something like this, let's say y equals x squared, it just doesn't give me any options. Now, but if I do something like y equal a to the x, it says add slider for a, and Desmos, for things that aren't an x or a y or a t or e, because e is a special number, if you put a letter in, it gives you this option to add a slider. So you just click on that, and then you see how it says a is equal to 1. I mean, a is equal to 1, but then you can go from -10 to 10, and you just, you know, if you slide that, it gives you, you can see how the graph changes. That's kind of the purpose of it. So, but because exponential bases A have to be positive, I want to change the range because it doesn't make sense if A is negative. So I click on one of the endpoints and I just put the number that I want, which is 1. And this tells me my slider will go from 1 to 10. And so as I move that, you see how the graph changes? You know, so that's just, I just want to make sure everybody knows how to do that. And the idea is you kind of can explore, like you say, oh, as X gets steeper, as A gets larger, the graph gets steeper. You know, why is that? And you say, oh, it's because the number A gets bigger, you know, and A squared, 3 squared is bigger than 2 squared. So if you go up more, you see how the graph gets sort of goes up, rises more quickly. So anyway, so it can be useful for doing things like that. Does that help, Angel? Or does that make sense?
Yes, it does. I actually have the same question, so thank you.
Okay, good. Yeah, yeah. And this kind of part of the purposes of these exercises is if you have a question, you can ask me or Sam. And again, these are skills I want people to have, which is why I'm asking. So, and then I didn't have the screen share on, but the other thing too is this: if you can ask each other and help each other out and things like that. I mean, one of the reasons I like small groups is that I think, you know, if you have a question, you can ask someone else a question, and maybe next time they're the one with the question, you know, and you can help them. So I think that's one of the things that are useful about these. Okay, you can learn off each other, and you also learn by explaining to others. Okay. So I'll let you. Are there other questions? Otherwise, I'll let you be for a bit and then come back.
No.
Okay,
That
sounds
was
good.
Yeah.
Okay, see you in a bit.
Mm-hmm.
Bye-bye. Hi, everybody. I'm just coming in to see if there are questions. And one question I have is not everybody in other groups has known how to add a slider, so I want to make sure everybody can do that. And would anybody like me to go over that?
I think I got it.
Okay. How about anybody else? Like I say, a lot of people haven't understood it. I don't want to do it if you already know how to do it, but if you don't, part of the purpose of this exercise was to make sure everybody knows how to do it, because I may incorporate that into a lab or a test or something like that.
I don't think I know how to do that.
Okay, good. I mean, not good that you don't know how to know, but I'll be happy to answer. Okay, so I'm going to go to share my screen. I was showing somebody else in another group, so let me take everything off. Okay, and so if I type something like y equal x, Desmos says, oh, x is a variable. And so it just figures it's a variable. And if I type something like y equal a and put an x on it, it says, oh, well, x is the variable, so he must want to vary what a is. And so, which I do want to do. This is for number 2, and it says add slider. So I just click on that, and it adds a slider for the next screen. I mean, the next cell, and it gives me a range of values from -10 to 10. And if I move this around, I see, at least if a is positive, I see a graph. But if a goes into negative, I don't. And so I could say, well, why is that? And it turns out the reason that is because if you take like x, a to the x could be like the square root, x could be 1/2. And if a is negative, you're saying take the square root of -1/2. It doesn't know how to do that. So I want to adjust a so it's positive. So I'm going to click on the left one, and it gives me the ability to change what I want a to be. So I want to change it from 1 to 10. Okay. And now when I slide it, I say, oh, there's the graph. I kind of say, well, what happens as a gets bigger? And what you see is the graph gets closer to the y-axis. So it gets steeper, the graph gets steeper. And I could ask questions like, why is that? And then as you go closer back to A, it starts to get flatter. And then when I get to A equals 1, if you say, well, okay, A is 1, it's looking at the graph, the horizontal line, Y equal A. So that's kind of what's going on there. Or Y equal 1. Does that help?
Yeah, thank you.
Okay, sure. So where are people in this? Are people in still working on 1 and 2, or have you gone into the others?
I'm on 1.
Okay, good. Take your time, and then I'll come back in. And the purpose of this today is just I want to make sure people can do sort of the basics with the log, and then the other. I just also want to reinforce that one of the reasons I like small groups is because you can ask each other questions, and I think that can be really helpful. Like if somebody asks you a question and you explain it, you're learning something, and so are they. And vice versa. And then if I have a question like, what do you see? Then if you discuss it, you can maybe get ideas from each other. So I really encourage you to be vocal and to talk to one another during these things. Okay. So are there questions about any of the material yet? Okay, I'm going to leave and I'll come back and see you later. Okay, I was giving you the ability to share. I didn't do that again today for some reason. But hi, I'm just coming in to see if there's questions. One thing that every group has asked, somebody in every group, is about how to use the sliders. So I don't want to waste your time and go through that if you know, but if you don't know how to add a slider, I want to make sure that you do. Because oh, go ahead.
I was confused on the slider.
Yeah, okay, good. Yeah, the purpose of this is sort of of today's thing is to get you to understand what a slider is and how to use it, and then also to just do some basic computation. So I'll share my screen, and I'll go through it. Okay, so I'll start from scratch. So if I do something like Y equal X, I get a line, and notice I don't get any options on that line. Okay. Now, if I do something like this, Y equal AX, it says add slider. And the reason is because what Desmos does is it recognizes X as a variable, Y as a variable, of course, T, usually the letter E it knows is that special number E. And so when you write a different letter, it says, well, they must want to, they must want to let A vary. So that's what's going on here. So for this problem, so we're going to do A to the X, and it says add slider. And so I do that, and then I get a range of numbers from -10 to 10. And if I move that, sorry, I did that kind of quickly. You can see what the graph looks like as A changes. And you see when A is equal to 1, for example, it's flat. And that's because it thinks A is 1. 1 to the X is always 1. So it looks like the horizontal line Y equal 1. If I go over here, past 0, the graph disappears. That's because exponentials don't exist for negative numbers. And that has to do with taking roots of negative numbers. So always A is going to be above 0. So I don't want to use that minus. I want to change the range. So I just click on one of the endpoints, and it asks me what I want A to be, and I want it to go from 1 to 10. Okay. And then now when I slide this, I get different graphs for each value of A. And as you get A closer, as A increases, you see the graph itself gets closer to the y-axis. So those are some of the questions I want you to look at. But for right now, does that make sense about how to add the slider?
Yeah.
Okay, good. And I may do that like on an exam, not an exam, but maybe on an exam, but maybe on a project or an exam or something like that. I just want to make sure you know how to do it. Okay, so back to this exercise. I encourage you all to talk to one another. one of the things I like about small groups is that it gives you that ability to ask each other questions. And I think you learn from that. If you're asking a question and somebody answers it, you're learning the answer. And then if somebody asks you a question and you have to explain it, that's deepening your knowledge. So I think that conversation is good. And I'm hoping you do that. And then for today's exercise, it's about looking at the graphs for 1 and 2 and understanding Desmos a little bit more. And then the other questions are all about how to use, just getting you familiar with logs, and which for some people can be confusing if you haven't seen it. So are there questions about other things in the lab besides the slider? And the other question I had is, where are people? Like, what number are you working on?
I didn't know how to use the slider, so I skipped to number 3 and 4, and I'm on 4 currently.
Okay, good. Any questions about those? Are those working out?
No, seem pretty straightforward.
Good. Okay, good. That's good to hear. How about others? Other questions? Where are you?
I'm finishing up 3.
Uh-huh. Okay. Again, any questions? Are you figuring it out okay?
No, I'm figuring it out okay.
Okay, good. Okay. Okay. I will see you all later. I'm just gonna let's see. I'm gonna do something. Okay. I just have to write something and then I'll leave. Okay, so I'll talk to you all later. Yeah, bye-bye. I'm just checking in to see where you are. And again, the sharing didn't get activated, so I just activated that. I wanted to see if you had any questions, and in particular, whether there were questions about how to add the slider. I know other, go ahead.
Adding the slider wasn't the hard part. It was the part where you would put restrictions on the slider.
Okay.
So like the 1 to 1 to 10, I had no idea how to actually do that for the slider.
And I'm happy to show you. This part of the purpose of today is just to make sure people know how to activate that and use it. So I want to make sure you do. Okay, so let me take these out. Okay, so Desmos, like if you write something like y equal x, it says x is a variable and it knows that. And if I were to write something like this, a different
Professor, we're looking at the worksheet.
Oh, okay. Let me go back.
Yeah.
Thank you.
Yeah, you're good.
Okay. How about that? Is that better?
Perfect. Thank you.
Okay, good. Okay. So again, if I write an x, then, sorry, let me get the graph so it's better. Desmos says, okay, that is a variable. So it doesn't give you any options. But if I write something like a to the x, it says, they want to let a vary and see what happens. So see how it gives me the option. So you saw that. And then let's say I want to have a go from 1 to 10, let's say. I just click on one of the numbers. So I just click on one number and now it opens up the option. So I set it 1 to 10. And then now I can slide this and it just says, oh, as that number a gets bigger, the line gets steeper. So that's kind of so the idea is you can explore things doing that. Like this would be a way to explore slope. And so what I'm asking you to do is to do a to the x and to see what happens as that changes.
That is helpful. Thank you.
Sure, yeah. Again, I want to make sure the purpose of this lab, one of them is to make sure people know how to do that. And the other is just to work with logs and get you more comfortable with that.
I did have a problem with actually doing the log on Desmos.
Uh-huh.
I did the log parenthesis X, but I couldn't add in the A.
Okay.
If I added in the A, it wouldn't graph anything.
Okay. Let's see. Oops, sorry, wrong one. Okay, y equal log. Okay.
Oh, that's how you'd enter it. Okay.
Yeah, you treat it like if what I did. You see what I did? I mean, you probably didn't, but I hit the. I'm typing that underscore, so it's that key that has the minus on it. I just hit shift.
Okay.
Does that make sense?
Yeah, mine's not. I'm trying to get mine to do it as you did it on yours.
Okay. So I do log, and then I hit shift, with a minus sign, and then the letter.
Okay.
And that gives,
still.
and then I have to add the X, of course.
Subscripts cannot be empty. Oh, that's okay. There we go. Got it.
Good. Okay. And these are kind of things I want to make sure you know how to do. So, so that again, today was to sort of learn a little bit more about Desmos.
Yes, that was helpful. Thank you.
Okay, good. So before I leave Desmos, other questions?
I don't think so. Thank you.
Okay. Do you have questions about other things?
No, Sam's been in here off and on. He's kind of answered stuff here and there for
Oh,
us.
good. Good. And just again, the purpose of the lab today is just to get you used to Desmos, learning more about that, and also to I just noticed a typo on something. And also just to get you more comfortable with the log. So I'm giving everybody sort of my group pep talk, and just encouraging you to talk to one another. When I ask these questions, like, what do you see? I'm hoping you're discussing those with each other, because you can learn from what each other says. It's like someone doesn't know how to do something and they ask somebody else who does know how to do it. That person that explains it is deepening their own knowledge, and vice versa, that maybe the next time they're the one with the question. So I just encourage you to talk and ask each other questions. Okay, so I'll see you all later.
Thank you.
Hello, I'm just checking in to see where you are on the worksheet and see if you have any questions.
We're doing pretty good. I don't think any of us have any questions. Thank you.
Good. So the logs are making sense?
Yes, sir.
Good. Good. Where are you? What number are you on?
I'm not sure what number it is. So
I'm working through 6. Is my mic unmuted? Oh, it is. Okay.
Yeah. You're unmuted. I can hear you. Yeah.
I was working through 6, and the e to the natural log of 5 plus x was definitely kind of throwing me for a loop.
Okay. So I'll try to explain that. So here's e to the natural log of x. Okay. I'll get to the question you have. What would that be equal to?
Isn't that just doesn't the e and the log e, don't they like kind of cancel out?
Exactly. So those cancel and you're left with x, because they're inverses. E and the log are inverses. So if I have something more complicated than an x, would it be any different?
Oh, okay. Yeah. Okay. That makes more sense. I forgot about that little bit.
Yeah. Right. It doesn't matter doesn't matter what's in here. It's still going to happen. And the reason this goes back to the fact that, let's say E is f of x. And you can do it either way. The natural log is then the inverse. So if I look at this one right here, I have f, that's the E of f inverse. and they just cancel and you end up with X, kind of like on the exam, even though it was a different function. Does that make sense?
Yeah, just kind of like the way that they cancel out. Yeah, I get that much.
Yeah,
better.
exactly, right, yeah. It doesn't look that way from here, but you have to say, oh, they're inverse operations, so they're like squaring and taking in a square root, something like that, or adding and subtracting, okay. Okay, other questions about the worksheet? Okay, and let me know, when you if you get done earlier, maybe you can help other people out. But let me know when sort of the group is done with it. Okay, I'll see you in a bit. Hi, everybody. I think I skipped you. Maybe Sam was in there or something. I just realized that I hadn't come to visit you, so I wanted to. One of the things I've been doing is to make sure that everybody knows how to use the slider within Desmos and how to set it up. And are there any questions about that?
I honestly just skipped over 1 and 2 because I wasn't really sure what to do.
Okay. I'm going to be. Oh, go ahead. Yeah.
No, you go.
Okay, Rachel, I'll be right back. Somebody just I think, got kicked out of the class and came back in. I want to let them in, then I'll come right back to you.
Okay, thank you.
So, yeah, sorry. Hi, Kristen.
Hi, I had to take a phone call and I had to log off for a few minutes. I'm really sorry.
Oh, no worries. That happens. What group are you in?
7, I think.
Okay, I'll just put you back in there. You just came back in, right?
Yeah.
Have you been waiting for it? Yeah, I thought I saw you. Okay, good. Okay, there you go. See you in a bit.
Thank you.
Yep, somebody had to leave and then came back and they couldn't get back in. Okay, so let me share with the slider. Just gonna make sure I got the right. Here we are. Okay, I'll take all this stuff off. Okay, so Desmos, if I type y equal x, it says they mean x. They must want x to be a variable, so they just type a graph. But if I put a number in front of that a, it says, oh, they must want a to vary, and so they give me this option to add a slider. So I do that, and then you see how it goes from -10 to 10. That's the default. But let's say I want to make it go from 1 to 10. So what I do is I click on that and I just add a 1 there, and then I put whatever number I want to have it end on there. And so now it gives me, when I slide this, it changes the slope of the line. And so it's a way to explore. Like I could ask the question, well, what happens when you change as the slope of the line AX increases? Well, you kind of go like this. You go, oh, well, the graph gets steeper, kind of obvious. So for this one, what I'm asking you to do is go to a to the x, and then I think here, and it started off like this, right? -10 to 10 was the default. I want to change this to 1, so I just click on that endpoint, and I'll change that to 1, and that should do it. And then if I slide this, I see how the graph changes. Okay. And it's a way of exploring, like this thing a, I could say, well, what happens is when the base of a to the x gets bigger? Well, you could slide this and you can see that the graph gets steeper. It gets closer to the y-axis. So anyway, does that make sense? Does that help?
Yeah, I think so, yeah.
Yeah. I know not everybody knew how to do this, and I want to be able to, if I assign a project or if maybe on some kind of exam, maybe to put a slider in, ask you to do that. Now I know that everybody knows how to do that.